Good evening, guys. Am I audible?
Yes, sir.
Yeah. Yeah. Shall we get started? Yeah. So I hope you're able to see my screen, right? Yes or no?
Yes, sir.
So you would have already learned probability in your 11th standard, right? And you're learning the same thing in 12th standard. Can someone tell me what is the difference between what you have learned in your previous year and this year? Just a minute, I'll be back. Yeah. Can someone tell me what is the difference between the one you learned last year and this year? Let's make it a bit faster because I know that most of you have already learned this chapter. Just basic level discussion and we'll close it. Anybody? So in your 11th grade, you would have learned about random experiments.
Yes, sir.
Right, once you learned about the random experiments. So what is the opposite of random experiments? You call it as deterministic experiment. First of all, what is an experiment?
Activities
What is an
which
experiment?
we perform.
So it is an activity which you perform where you have a definite output or a definite outcome, right? So when you talk about the experiment, the prefix is random or you have deterministic. So random experiments are the ones where you're not sure of the output, whereas deterministic experiments, you're sure of the output that it is one which is 100%, right? Now, we would have learned about sample space. So what is sample space? Sample space is a universal set of all the possible outcomes. You put it in a set, you call it as a sample space, right? Then you discuss something called as an event. So what is event? So we have studied about random experiment and sample space associated with experiment. So if you consider the experiment of tossing 2 coins, what are all the possible outcomes? Head, 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 tail, head, and tail, tail. Okay. So in those outcomes which correspond to the occurrence of exactly one head, if I put a condition like this, so each occurrence in that particular experiment is what is called as an event, right? So why this event is important is because you talk about the occurrence of events or the event not occurring at all, which is called as impossible, and the counterpart of it is called as sure events, right? Then you have something called a simple event and compound event. The most important of everything is this one: mutually exclusive and exhaustive. What is the difference between these two? This is what I want.
So if two events occurs, one event does not affect the another one is exhaustive, and one which does not affect is mutually exclusive, and if it affects, it's exhaustive, right?
Example.
For tossing a coin, so first whatever the output is, it doesn't affect the second one, right?
Okay, so getting a head and getting a tail, both are mutually exclusive events. So the occurrence of one does not affect the occurrence of other. right? Then what are exhaustive events? This is very important for Bayes theorem.
So
This is
this
very important
affects
for
the other one, right?
Then there is a wrong understanding. Exhaustive is not the counterpart of mutually exclusive. Exhaustive means you're exhausting something. What is the meaning of this? Means somebody is mic is on. No, then you have a wrong understanding. Exhaustive means you have utilized all the events from the sample space. Okay, see, for example, if you consider the experiment of throwing a die, then what is the sample space? 1, 2, 3, 4, 5, 6. Okay, let me define an event A, where the event A says that the number appears is less than 4. So less than 4 means 1, 2, 3 is the possible outcome of that particular event. B is what? A number greater than 2 but less than 5. So what are the outputs? 3, 4. Then C, a number greater than 4 appears. It is 5, 6. Now what are the events? 1, 2, 3, 3, 4, and 5, 6. Now tell me, if I take A and B, can I call it as exhaustive events?
No, right?
Yeah, why?
Because 5 and 6 are not there.
Similarly, B and C,
No.
A, B, C put together.
Now we can call them.
Now it is. So A union B union C, if it is equal to sample space, then this is the condition for exhaustive. Means you are exhausting, making use of the whole sample space. Whereas when you talk about mutually exclusive events, what should be the condition between them? Event A and event B should not have any intersection. So it is a null set. If they are disjoint sets, then you call them as mutually exclusive event. So this year you would have learned about Bayes theorem. So for you to apply Bayes theorem, what is the important condition? Can someone tell me?
Independent.
More than that, they should be mutually exclusive and exhaustive at the same time. Only then you can apply Bayes theorem. Okay. So when I come to that point, I'll explain it. So is it clear, guys? This is the point I wanted to stress upon: mutually exclusive events and exhaustive events. The remaining part of the story goes to your 12th standard. Is there anyone having any doubt?
No, sir.
No? Okay. We'll discuss about we'll go to the next part. So directly they are jumping into the concept of conditional probability. What is this conditional probability? So name itself is suggesting, right? Conditional probability. What is it?
So the sample space is again some group of events instead of the whole set.
Okay. What you say, I'm able to understand. I'm able to understand. Can you make it? Can you put it in some other way?
So the event, the event of occurring where the sample space is the output of some other event.
Okay. Okay. I'm able to understand. I'll come to that point. So till now we had been discussing about probabilities of finding the methods. So we discussed the methods of finding probability of events. If we have two events from the same sample space, does the information about the occurrence of one of the events affect the probability of the other event? That is what we need to understand. Let us take an example, okay? The best way to learn probability is by example only. There is no such theory. Let us try to answer this question by taking up a random experiment in which the outcomes are equally likely to occur. What do you mean by equally likely? Every possible outcome has the same value of probability. Okay, that is the meaning of equally likely. Am I right? So if you consider the experiment of tossing 3 fair coins, then what will be the output, guys? Can someone tell me? how will you write the output of 3 fair coins tossed at the same time? So you can write as head, 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 tail, 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 head, head, tail, tail, head, head, tail, tail, head, tail, head, tail, head, tail, head, tail. Right? So this is going to be the sample space. Since the coins are fair, we can now assign the probability of 1/8 to each sample point. Means each outcome has a probability of 1/8. You're able to understand this? So that is the meaning of equally likely. Right? So if I define an event E, that at least 2 heads appear. Tell me what are all the outcomes that are possible. At least 2 heads means minimum 2 heads, maximum 3 heads. So head, head, tail, tail, head, and you have head, head. Right? And F be the event where the first coin shows a tail. So if the first coin has to show a tail, and TTT. Right? So if I ask you what is the probability of event E to occur, what will you say? So what is the probability of event E to occur? So
4
it
by
can
8.
either be, how did you get that 4/8? I'm concerned about that part. That is more important.
4 events have occurred and the total sample space is 8. So 4 by 8.
Yes, so 4 out of 8. So that is one way of solving. Since they use the word equally likely, here alone I'll explain it. So probability of E, they told it as probability of you getting head, 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 or. When I say or in probability, am I supposed to do addition or multiplication? When we say or in
Or is
probability
addition.
and or is addition, that is union, plus probability of head, head, tail, plus probability of head, tail, head, plus probability of tail, head, head. So can I say something like this? Now similarly, individual probability is 1/8 plus 1/8 plus 1/8 plus 1/8. So this also is going to give you 4/8. Just we gave a different approach to it because this concept comes from last year's topic only. I'm not sure if you remember the probability of an event. This is the thing. You can take this example and see it later. So it comes from this concept only. Similarly, what is the probability of F? First coin shows tail. So 4 outcomes are there out of the 8. So 4/8 is 1/2. Now, what is E intersection F? That is, what is common between E and F? That is tail, head, head is what is common. Correct? So that is the only outcome that is possible. So if I ask you, what is the probability of E intersection F? What will you say? Probability of getting tail, head, head. It is how much? 1 out of the 8 possibilities. So this is simple, right? Now, why did we do all these things? Right? Because this is where we are going to implement something called as a condition. That is why it's called as conditional probability. You're saying occurrence of one event should happen under the occurrence of something else. Okay. Now, suppose we are given that the first coin shows tail. So if they say first coin shows tail, which event will you take into consideration? It is F. Because that's what they say, first coin shows tail. Then what is the probability of occurrence of E? So what is the meaning of this? So if you can someone tell me the meaning of this point? Though it's a statement, how am I supposed to interpret it mathematically? I need to quantify this value, right? How do I do it? Nikhilesh, can you tell me the meaning of this term?
So here E is the sample space. And
What meaning? What is the meaning they're asking? I want the meaning of the statement. So find the probability of F to occur, knowing that E has occurred. Is that what you're going to write? So you know that given that E has occurred, then what will you write?
So I have
what
a
will be the
doubt,
value?
sir.
Tell me.
Shouldn't it be P of E occurring when F occurs. So like P of E by F.
Oh, sorry. Yeah. What if occurs, then what is the oh, sorry, I read the question wrong. So probability of E given F. So what is the meaning of this? Then which one will be
Getting
taken?
E when F occurs.
So probability of you getting. So what is it? So probability of you getting E, known that F has occurred. So we know that individually the probability of E is how much? Individually the probability of E is half. How did you get it? You got it from 4 by 8. But if I give you a condition like this, what is the probability of E? You know that F has already occurred. So what will you say?
So
The
P
answer
of
will be,
E by P of E union.
so now how much is it? Is it union? How much is the value?
I mean
E
the
intersection
value.
is.
I mean
So
that is what I meant, sir.
okay, so what is the answer? You are saying, you're trying to say P of E intersection F is the answer?
Yes, sir.
No, sir. That divided by 1 by 2. So that will be 1 by 4.
Why is it 1 by 2?
Because
So that
given
is
that
like you're telling
F occurs.
P of E intersection F divided by P of F. You're saying this is the formula for this thing, correct?
So because this is for, I mean,
But
E.
yeah.
So
You tried it.
for that to be in the numerator, the output should be there, right? So E union F must be there.
Correct. So probability of E given F means, listen to this carefully. I am putting a condition that I am not concerned about the whole sample space. Rather, I am trying to restrict my sample space to which event? I am trying to restrict my sample space to F. Okay. So listen to this carefully. What is the basic definition of probability, guys? What is the basic definition of probability? Total number of, favorable number of outcomes divided by the total number of outcomes, right? Correct? So
Yes.
what I'm trying to say is, I'm reducing my sample space from n of S to, I'm reducing it to n of F. So n of F, and what should be in the numerator? I need to choose only those number of elements that are there from the set E, which are common to set F. Guys, are you able to understand what I wrote? I'm just giving you a different perspective. Are you able to understand the meaning? So they're asking what is the probability of E given that F has occurred means I'm trying to restrict my sample space by restricting the number of elements from 8 to how much value? What are the number of elements in the bigger samples in the sample space? They are 8. But what are the number of elements that are there in the set F? They are 4. That means I'm reducing my denominator to number of elements in the 4. In those four elements, what is E concerned about? I want E to occur, knowing that F has already occurred. So in event E, where is tail coming for the first time? How many times is the tail coming for the first time? It is this part. So this one and this one are common. So I gave number of elements in E intersection F divided by N of F. Now tell me one thing. N of E intersection F divided by N of S, the whole divided by N of F divided by N of S. So what did I do here? Mathematically, I divided the numerator and denominator with the number of elements in the sample space. What does this give us? Right, if you understand this, there is nothing, okay, you'll never forget it. Please understand, try to understand. Though the logic might be slightly tougher, but put some effort to understand. Did you understand this step? So what is the number of elements in E intersection F divided by the number of elements in sample space called as? This is what we call it as probability of E intersection F divided by this number of elements in F divided by the number of elements in sample space is what we call it as probability of F. Guys, is this clear? Is this point clear? Okay. Now you understood how the formula has actually come. So that's what they have given. Okay. Now, from here, since we understood the logic, we call this kind of a probability as conditional probability because we are setting a condition. That's it. As simple as that. Right. So if E and F are two events associated with the sample space of a random experiment, then the conditional probability of the event E, given that F has occurred. So how do you write it? Probability of E, given that F has occurred, is equal to how much? Probability of E intersection F divided by probability of F. Means you make, like how Niklesh told, you make F as the sample space in the denominator. Right. So what are the properties of conditional probability? If E and F are events in the sample space of an experiment, then we have probability of sample space given that F has occurred is what? So probability of sample space given that F has occurred is equal to probability of sample space intersection F divided by probability of F. So sample space is universal set intersection any set is going to be the smaller set and divided by P of F. Answer is going to be 1. So though it is mathematically occurring, I hope you are able to understand what I'm trying to say. So what is the probability that an event from the sample space is going to occur, knowing that a part of it from the smaller set has already occurred is 1, means it's a sure event, 100% probability. That is the meaning of it. Okay. Similarly, if A and B are any two events of a sample space, S and F is an event of S such that P of F is not equal to 0, then what can you say? P of A union B given F is equal to what? Is equal to what? P of A given F plus P of B given F minus P of A intersection B given F. Right. So how did you get this? So how did you get this?
The formula we studied last year. By applying it in the Venn diagram, we get a formula. So
yes, that's called as de Moivre's formula. Okay. So probability of A union B. So this will be what? Probability of A union B intersection F divided by probability of F. Did you understand what I wrote it here? Are you clear with what I wrote it here? So A union B, if I call it as C, how will you write probability of C given F? So you'll write as probability of C intersection F divided by probability of F. This will be equal to how much? A union B intersection F is how much? So if you use the distributive law, then you will get P of A intersection F union P of B intersection F, the whole divided by P of F. Right. So from this, we need to subtract something. Minus. So if I call this as theta, okay. So what is C intersection F? I can write it as. Okay. Let me come to this point. So the formula is A intersection F union B intersection F minus A intersection B intersection F, the whole divided by F. Okay, just add probability before this. Now tell me what is this thing? So probability of A intersection F divided by probability of F. Union means I can put a plus, right? Probability of B intersection F divided by probability of F minus probability of A intersection B intersection F, the whole divided by P of F. Now tell me guys, so what is this? I can write it as according to a conditional probability. Probability of A given F plus this I can write as probability of B given F minus probability of this thing A intersection B given F. So this is going to be the formula. So if A and B are disjoint sets, what is going to happen? A intersection B will be null set, so the probability will be 0. Okay. And the third property that we are going to see is probability of E complementary given F is 1 minus probability of E given F. So how to solve this? So they're using the first property. Property of S given F is equal to 1. So probability of, how can you write the sample space? The sample space is the union of E and E complementary given F is equal to 1. Then what can we write this as? So this is from property number 2. So property number 2, what I'm going to use? So it will be probability of E given F plus probability of E dash given F minus 0 is equal to 1. So probability of E dash given F will be equal to 1 minus probability of E given F. So these are the three properties that you need to know to solve the problems in this exercise. Shall we solve them faster? So I'm sure you would have practiced, right? So example 1, probability of A is 7 by 13, probability of B is 9 by 13, probability of A intersection B is 4 by 13. So what is the probability of A given B? So that is probability of A intersection B divided by probability of B. Guys, you know what will come in the denominator, right? Whatever is in the denominator here, write the same thing in the denominator here also. So probability of A intersection B is 4 by 13 divided by probability of B is 9 by 13. Answer will be 4 by 3. Sorry, 4 by 9. Second one. A family has 2 children. What is the probability that both the children are boys given that at least one of them is boys? So always write down the sample space. So what is the sample space? It's like 2 points only, right? Yeah, you have to write it with this thing in the ordered pair. Boy, 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 girl, girl, boy, girl, girl. So if you write them in this kind of a format, 1 minute. Okay. So what is the probability that boy, both are boys, B comma B, given that at least one of them is a boy. So F is equal to what? Boy, girl, girl, boy, right? So what is the probability of E given F? It will be probability of E intersection F divided by probability of F. So I know the answer directly. What will you do? It is actually probability of E divided by probability of F. One number of elements in E divided by the number of elements in F. That is going to be the answer. So intersection is 1 divided by 3. Right? Guys, there.
Yes,
Did you
sir.
understand how I got this 1 by 3? Anybody having any
Yes,
doubt?
sir. Got it, sir.
Got it right? Okay. So So 10 cards numbered 1 to 10 are placed in a box, mixed up thoroughly, and one card is drawn randomly. It is known that the drawn card is more than 3. What is the probability of a number? So how to solve? So sample space, I told you, right? Always start with the sample space. 1, 2, so on till 10. What is event A? So it is known, means that is given. It is known that the number on the card drawn is greater than 3 what is the probability that it is an even number? So what is the probability that it is an even number known that the numbers drawn are greater than 4? So you need to give some notation to it. What is event A? 2, 4, 6, 8. Then until 10. So what is the probability of given B? The A into B divided by B. So tell me one thing. In this case, is it possible to find probability of B given A? What probability of A? It will be probability section A by probability of A. Guys, tell me one thing. Will this exist in this question? You can get this. Did you understand what my question is? Will this give a finite output? If I write probability of B given A. So B is 4, 5, 6, 7, 8, 9, 10. A is 2, 4, 6, 8, 10. Guys, there I asked a basic question. They can ask you this kind of a question also. You can give a answer is when I don't know. You have to see. So what is it? What is the answer you are going to get? You will get 4, 8, 10. 1 out of 5. Yes, it is possible. So sometimes what will happen is this number, no probability of A will be lesser than probability of B intersection A. That time there is a possibility that the reverse condition will not take. Be careful. Fortunately, in this question, that is probability of A given B. That is probability of A intersection B divided by probability of B. What is the answer? 1, 2, so 2, 4, 6, 8, 10. But what is the probability of A intersection B? It is 4 divided by 1, 2, 3, 4, 5, 6, 7. 4 out of 7. Yeah, 4 by 7. I directly wrote it. I hope you are comfortable with that, right? It is actually 4 by 10 divided by 7 by 10. Example 4. In a school, there are 1,000 students, out of which 430 are girls. It is known that out of 430, 10% of girls study in class 12. What is the probability that a student chosen randomly studies in class 12, given that the chosen student is a girl? What is the probability that a student chosen randomly studies in class 12? So that should be in the numerator. Student chosen is in class 12. So what about F? So chosen student is a girl. So probability of E given F is equal to probability of E intersection F divided by probability of F. So how to take the data, guys? Tell me how to collect the data. You guys help me. So if I ask you, what is the sample space for E? What will you say? Or I ask you, what is the probability of E? So 430 are girls. 10% of 430 study in class 12. So I don't need probability of E. I need probability of F here. So what is probability of F? 430 out of 1000. Okay. So what is the probability of E intersection F? What is the probability of E intersection F? So that is the number of elements in E intersection F divided by the number of elements in the sample space. So E is what? 12th standard girl. F is a girl. So what is the intersection? 10% of 430 is 43 divided by the number of elements in the sample space is 1000. So it will be 0.043. This will be 0.43. Now you can solve it. 0.43 divided by 0.043, that is 0.1. So if you multiply 0.1 with 100, there is 10% chance for this kind of an event to occur. Because I'm not sure if you're able to feel like able to understand? No doubts, right?
No doubt, sir.
Good. Okay. So a die is thrown 3 times. So die is thrown 3 times is same as 3 dice rolled together. Events A and B are defined as below. A is equal to 4 on the third row, B is equal to 6 on the first and 5 on the second row. Find the probability of A given that B has already occurred. So if you write the sample space, you will have 216 outcomes. How did you get it? It is 6 power 3. It is 216. Out of those 216, you will have ordered triplets. Right? So in those ordered triplets, if I take event, 4 should occur on the third row. So first row can be 1, second row can be 1, third row will be 4, or 1 2 4, or 1 3 4, 1 4 4, 1 5 4, 1 6 4. Okay, that is a series with 1. So similarly, if you start with 2, 2 1 4, 2 2 4, 2 3 4 till 2 6 4. Similarly, if I keep writing, I'll get it till 6 6 4. How many such elements will I get in this? 6 6 6 6 6 6. It'll be 36 elements. Right? B is 6 on the first and 5 on the second. So 6 on the first and 5 on the second, how many such are there? 651, 652, 653, 654, 655, 666. Okay, this is 6 outcomes. So what is the probability of A given that B has already occurred? So that will be probability of A intersection B divided by probability of B. So what is the probability of A intersection B? What is the probability of A intersection B? There is only one event, right? That is 1 out of, okay, you want to take it like that. That is correct. 1 out of 216. What is the probability of B? 6 out of 216. Cancel them. Yeah, it will be 1 by 6. Did anyone understand? I directly wrote it as 1 by 6 because I took B itself as a sample space. That is why I wrote it as 1 by 6. Right. Example 6. So die is thrown twice and the sum of the numbers appearing is observed to be 6. What is the conditional probability that the number 4 has appeared at least once? So tell me. A die is thrown twice. So how many outputs are there? 6 power 2, that is 36 outputs. Sum of the numbers appearing is observed to be 6. So sum of the numbers is observed to be 6 means. Okay. What is the conditional probability that number 4 has appeared at least once? So what is the conditional probability that 4 has appeared at least once, knowing that the numbers appearing are supposed to be added up to 6. So event E will be how much? Number 4 has appeared at least once. So 4, 1, 4, 2, 4, 3, 4, 4, 4, 5. Similarly, I can start with 1, 4, 15, 16, sorry, 14, 24, 34, 44 is not there, 4, yeah. So 5, 4 and 6, 4. So this is E. What is F? F is an event where the sum of the two numbers should be 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. So what is the probability of E intersection F? So how many elements are there which are common in E and F? So you need not write that 1 by 216 always. You can remember it like this. Probability of E intersection F divided by the number of elements in F. So what are the number of elements which are common in E intersection F? 1, 5, 2, 4. So 2, 4 is common. 3, 3 will not be there. 4, 2 is common. So 2 out of 1, 2, 3, 4, 5. So 2 out of 5. Right. So are you guys clear with this? You guys can do this exercise, right? Yes or no?
Yes.
Okay. So I'm moving on to the next one, that is multiplication theorem on probability. So if this comes from the concept of this one only, conditional probability only, it's just rearranging the mathematical expression. If I take E and F to be two events associated with sample space S, then you can say that the set E intersection F denotes the event that both E and F have occurred. Okay. In other words, E intersection F denotes the simultaneous occurrence of the events E and F. Right? So the event E intersection F is also written as EF. This is another notation. Now, very often we need to find the probability of the event EF. For example, the experiment. So let us take this example. For the example, the experiment of drawing two cards, one after the other, we may be interested in finding the probability of the event a king and a queen. Okay, so the probability of EF is obtained by using the conditional probability as below. Now listen to this carefully. So what is the question? For example, in the experiment of drawing two cards, you're drawing it what? You're not drawing it simultaneously. You're drawing one after the other. We may be interested in finding the probability of the event a king and a queen. Means the first draw I need to get a king, and the second draw I need to get a queen. Okay. Now we know that the conditional probability of event E given that F has occurred is denoted as what? Probability of E given F. So what will you get? You will get probability of E intersection F divided by probability of F. So if you want to find the probability of E intersection F, take this to the other side. That is the meaning. And means intersection. That is the meaning of what they are talking here. So probability of E intersection F is equal to probability of E into probability of F given E. Or I can write probability of E intersection F is equal to probability of F into probability of E given F. So this result shows the multiplication rule of probability. Is there anyone having a doubt in this? So it's a very simple thing. Probability of E given F is equal to probability of E intersection F divided by probability of F dot. This goes to the other side. Then I can say probability of E intersection F is equal to probability of E given F into probability of F. So whatever is the denominator, you need to multiply with the probability of that value. That is what we call it as multiplication rule of probability. Okay, let us take an example. There is a bag which contains 10 black and 5 white balls. So 10 black and 5 white balls. 2 balls are drawn from the bag, one after the other without replacement. Okay, this is where the conditional probability comes, because one is dependent on the other. Can someone tell me, if had it been with replacement, do you need to use conditional probability? Okay, let me put the question a different way. What do you think will be the change that you can observe when the experiment is done without the replacement? Can someone tell me what that without replacement is? Why that without replacement is important? I am trying to discuss. Okay, listen. There is a bag which contains 10 white balls and 10 black and 5 white. So what are they doing? They're drawing 2 balls. So suppose in the first draw you got a white ball, black ball. Okay. Now, what is the probability of you getting a black ball in the first draw? So probability of black in first draw is how much? It is 10 out of 15. Now, what is the probability of you getting a black in the second draw? What is the probability of you getting a black in the second draw? This is where an important question that we need to ask is, are you replacing the first ball or not? So are you doing it? So when you're not doing it, what change will occur? Now, how many black balls are left out? 9 out of total how many balls are there? 14. So this has got affected. If you look at the denominator, the sample space itself has got affected. Right? Are you able to understand? So if I assign an event E, which is black ball in first draw, so what is the probability of E? That will be 10 out of 15. Now, I will not assign F directly, rather I will assign an, okay, let me take event F, which is getting black ball in second draw. Then what does this 9 by 14 represent? Is it probability of F or probability of F given E? So what is the right answer for this? What is the answer, guys? So is it probability of F or probability of F given E? What is right?
So could you show the question for me? Probability of X, sir.
It is not probability of F because you did it without replacement. Means the probability of getting black ball in the second draw, knowing that in the first draw you already got a black ball, is 9 by 14. Because what has happened, this is what I'm trying to stress upon. What has happened? The sample space itself has got changed. So it is not F, it is rather F given E. So what is that you need to find is probability that first draw is black and the second draw is also black will be equal to probability of E into probability of F given E. So what is the probability of E? That is 9 by 14 into probability of F given E is 10 by 15. This will give you the answer. Okay, actually you can directly do it also. You don't need this formula and all. So first, what is the probability that is happening? It is 10 out of 15. And in the second case, you are getting 9 by 14. That is the answer. You actually need not apply the formula at all. But since it is subjective exam and you need to show certain steps that you know the concept, we need to apply this formula. You're able to understand, actually, you can solve the problem in single step. So similarly, you have multiplication rule of probability for more than 2 events also. Okay, that is given here. Now, so that is probability of E intersection F intersection G is equal to probability of E into probability of F given E into probability of G given E intersection F, or this is also equal to probability of E into probability of F given E into probability of G given EF, or E intersection F and EF are the same. Okay, let's see an example for this. 3 cards are drawn successively. Never forget this word successively. So when I say successively, things have happened without replacement. Okay, without replacement from a pack of 52 well shuffled cards. What is the probability that the first 2 cards are kings and the third card drawn is an ace? So what are they asking? What is the probability of you getting king and a king and an ace? Okay. So actually you need not apply this formula and all. I'll tell you how to do it directly. You verify the answer, then you apply the formula to get the answer. So what will the answer be? Probability of K. So getting the king in the first draw is how much, guys? How many kings are there?
4 kings.
Out of?
52 cards.
Okay. So what is the probability of getting king and a king? 4 out of 52 into?
3 by 51.
3 by 51. So what will be the probability of you getting king and a king and ace? 4 out of 52 into 3 out of 51 into?
4 by 50.
Why 4 by 50? Because 4 A's are there out of the 50 remaining cards. So that will be the answer. Did you understand how they came? Yes or no? So there,
Yes,
only thing is you will be applying the formula P of K into P of K given K into P of A given KK. That's it. And after one after the other, that's it. See, for example, let me put a question like this. Let's see how much your brain is working. What will happen? P of A intersection B intersection C intersection D. So probability of A into probability of
B.
B given A into probability of C given AB into probability of D given ABC.
ABC.
You're able to understand? That's it. So just
That is if it's not replaced, right, sir?
Sorry?
This P by
It's not?
A by, with like P of B by A, P of C by AB, that's only if it's not replaced, right? So the card we draw is not
Yeah, it is
replaced.
not replaced. Yes. Why we are doing it is because the reason is the sample space is changing. You are able to understand the denominator is changing every time. See, it's going in a decreasing order. Why is it happening? Only because you're not replacing the stuff. Had you solved the same problem with replacing, then things would have been different. 4 by 52, 3 by 52, and 4 by 50. Because they are sequential process. That's the logic. Nothing else. Okay. So if you do something in sequence, there is something called as fundamental principle of counting in permutations, combinations. Right. The same logic is getting applicable here. Right. Now comes another question. Independent events. So let me explain this. So if you consider an experiment of drawing a deck of drawing a card from a deck of 52 playing cards in which the elementary events are assumed to be equally likely, means every event has an equal probability of how much? 1 divided by 52. That is the meaning of equally likely. So if E and F denote the events, the card drawn is spade and the card drawn is ace respectively, then what can you say? So what is the probability of E? So if the card drawn is spade, since it is equally likely, how many spades? How many spades did you? How many spades are there?
First spade.
4.
13.
Spade is that. You have 13 out of the 52. What is the probability of F? How many A's are there? A's are 4.
4.
Because they are numbered. So 4 out of 52. It will be 1 by 13. So even E and F denote. Then what is the probability of event E and F to occur? So what is the probability of event E and F to occur? What is the meaning of this? So I want an ace with a spade. What do I want? I want an event where the card drawn is an ace with a spade on it. How many such cards will be there?
1, sir.
1 out of the 52. Right? So what are they asking us to calculate? So what is the meaning of probability of E given F? So they're just trying to show us the difference between the numbers. So what is the probability of E given F? So it will be probability of E intersection F divided by probability of F. So what is the probability of E intersection F? 1 by 52. What is probability of F? 4 by 52. So there is 25% chance of this to occur. So what is the meaning of this? The probability of E given F means what is the probability of you getting a spade known that the drawn card is an ace? Is 1 out of 4. Right. So what is the probability of F given E? What is the meaning of probability of? So what is the probability of you drawing an ace known that the card that is already drawn is a spade? So that will be probability intersection divided by probability of. So what is probability of E intersection F? That is 1 by 52 divided by what is the probability of E? Probability of is 1 by 4. So cancel them. So you get 1 by 13. So what is the So what is it you're able to understand? 1 by 13 and 1 by 13, which is probability of F only. So probability of F given E is the same as probability of F. Probability of E given F is equal to probability of E given F is equal to probability of E. So you're able to understand. So what is the meaning of this? Conditional probability and the exact probability are giving you the same value of probability. Means what do you call these kind of events as? These kind of events are what are called as independent events, because if I'm trying to calculate the conditional probability of E given that F has occurred and getting the exact probability at that of E, meaning the occurrence of F is not affecting the occurrence of E. So they are independent events. Okay. So when I say two events are independent, so you can say two events E and F are said to be independent if probability of F given E is equal to probability of F and probability of E given F is equal to probability of E. Now by using the multiplication rule of probability, I will get probability of E into probability of F given E. But what is probability of F given E? It is probability of F itself. So probability of E intersection F is equal to probability of E into probability of F. This is the condition for independent events. So here I want to stress one important point. Many people get confused between independent and mutually exclusive events. So what is the difference between both? So what is the difference between independent events and mutually exclusive? So when I say mutually exclusive, A intersection B should be a null set. You understand? So when I say two events are mutually exclusive, then A intersection B will be a null set. Whereas when I say two events are independent, probability of E intersection F will be probability of E into probability of B. Okay. Now the next one is the vice versa. If E and that is a corollary. If E and F be two events associated with some random experiment, then E and F are said to be independent if this condition is occurred. Okay. So I'll do one last problem and we can wind up. there is a die that is thrown, event E. So if E is the event where the number appearing is a multiple of 3. So when a die is thrown and you have a number which is a multiple of 3, what will I get? I'll get 3, 6. And FP an event where the number appearing is even. That is 2, 4, 6. Then find whether E and F are independent. So how can I do this? Probability of E intersection F is how much? So what is the probability of E intersection F? That is the number of elements in E intersection F divided by the number of elements in sample space. The elements are common are 1 out of 6. What is the probability of E? That is 2 by 6, which is 1 by 3. Probability of F is 3 by 6, which is 1 by 2. Okay. So probability of E intersection F is equal to probability of E into probability of F. So can you say they are independent? Yes, they are. Right? Guys, this is the basic. So with the hope that you can solve this exercise, I'm leaving it to you. Next class, I'll discuss Bayes' theorem. Then I'll go with the distribution, probability distribution. Is it clear till this step? Any doubt?
No doubts.
No.
Okay, then we can wind up.
Thank you, sir.
Thank you, sir.
Yes, sir. Yes, sir.